Hello everyone, my name is Juni from Korea Kim Foreign School, and today I'm going to be talking about the unsolved mysteries of time. So as you all know, time is an extremely important part of our lives. We use it to determine when to do certain things for the day, and although it isn't something we can physically interact with, it will always be there and will continue to flow. But despite its importance, us humans generally don't think much about the way it works. We just let it do its thing because most of us believe that time is constant, and to manipulate it sounds like something straight out of a sci-fi movie. A minute will always last a minute no matter what, and to alter that would be something out of this world. However, it's been stated by Einstein that time isn't absolute. The rate in which time flows is greatly proportional to where we are and the speed in which we're traveling in. So today, we're going to be exploring different topics about time, and I can guarantee that it will pique your interest. So let's start off by talking about how time itself even started. Time is always flowing and will continue to flow as it has been for the past billions of years. But when and how did time start? The Big Bang is a theory which suggests that the universe consisted of extreme density and heat while maintaining the size of a pinhead at the same time. In just fractions of a second, it started going through a sudden expansion and created the universe that we all know today. A lot of scientists will use this theory to explain the origin of the universe, and it's widely accepted as the beginning of space, time, and energy. Therefore, some scientists will say that time started around 13.8 billion years ago when the Big Bang happened. But if time didn't exist before the Big Bang, how did the universe even condense itself in the first place? And that's where the egg periodic theory comes into play. This is an alternative theory to the creation of the universe and suggests that it had neither a beginning nor an end. And because of this theory, some scientists claim that time existed long before the creation of our universe. However, it's only natural to assume that everything has a beginning, including time. After all, everything has to start from somewhere, right? So the egg periodic theory doesn't sound too convincing either. So if we go back to our initial question as to when and how time started, answering this question would be impossible at the moment because nobody in the world knows. But despite not knowing much about how time started, we actually have a pretty good understanding of what time itself is. If you ask Google, it will tell you that it's the indefinite continued progress of events, or that it's the measure of time taken by an activity. And although these are all correct definitions of time, it doesn't really tell us what it is physics-wise. And as you all know, the world we live in is three-dimensional. We have the x, y, and z coordinates. However, when Einstein wrote his theory of general relativity, he wanted to show the effects of gravity by creating a graph that could visually depict the curvature of space. He figured he couldn't do this with a regular 3D diagram, so he decided to create a 4D diagram instead. Now, I'll talk more about space-time later on, but for now, all you need to know is that the major difference between a 3D and a 4D diagram is that a 4D diagram incorporates time as a new coordinate. This made it easier for scientists to study and graph the effects of gravity. And this is also why time is considered to be the fourth dimension in science. Now let's talk about the end of time. Geoffrey Chaucer, an English poet, said that all good things must come to an end. And unfortunately, this may apply to time as well. The Big Rip is a theory which suggests that the universe will eventually expand at a rate so fast to the point where it will be unable to hold itself together. In the end, our universe will tear itself apart and all atoms will be destroyed. If we assume that the creation of the universe is what started time, we can say that the end of the universe would result in the end of time. Therefore, time could completely stop flowing in the future if the Big Rip happens. However, it's said to occur in around 20 billion years from now, so it's nothing for us to be worried about at the moment. But what happens after the Big Rip? Some scientists believe that after our universe is destroyed, the Big Bang will simply happen again, which results to the creation of a new universe. And when that new universe is created, time will also start flowing once again. So it will be a constant loop from the Big Bang to the Big Rip over and over again. It's also possible that the Big Rip already happened in the past, and we're living in that new universe right now. However, saying that the Big Rip never happened and that it will never occur in the future is also a fair argument too. This is because it's just a theory. So now that you understand now that you know about the beginning and the end of time, let's talk about time dilation. Most people are under the assumption that time is constant. However, it's a well-known fact within scientists, especially physicists, that the rate in which time flows can be changed. An example of this would be time dilation. It's when two different people experience the same event at different times. And at first, this may sound like nonsense, but It's been proven by many experiments in the past. For example, a famous one would be the Hafili-Keating experiment, which was conducted in 1971 by two scientists. A set of clocks were placed inside an airplane traveling west, another set were placed inside an airplane traveling east, and the final set was placed on Earth's surface. Both planes took off at the same time and had to travel around Earth once. Let's say that the plane traveling west is plane A, and say that the plane traveling east to be plane B. Since Earth rotates eastward, plane A was able to arrive at its destination in the smallest amount of time, which means it had the greatest velocity. Meanwhile, plane B was able to arrive at its destination in the greatest amount of time, which means it had the lowest velocity. After the experiment, the set of clocks that were in plane A and plane B were compared to the clocks that remained on Earth's surface. The clocks that were in plane A showed a greater change in time, while the clocks in plane A showed the complete opposite with a smaller change in time. And although the differences in time between the clocks were in nanoseconds, it still proved that time was affected by the speed in which the planes traveled in. So now that you understand how speed affects time, let's shift our focus to gravity. Everything in this world has gravity as long as it has mass. This means even you and I have gravitational fields of our own. But unfortunately, they don't amount to anything significant because of how small our masses are. However, stars and planets are a completely different story. Since their masses are so big, they come with very powerful gravitational fields. They're so powerful that they're able to bend the space around them. Bending space also means you're bending the time within that space. So bending space could be seen as the same thing as bending time. Scientists depict how strong a gravitational field of a star or a planet is by drawing the curvature of space around it. These models are called spacetime. At first glance, it may look like a regular 3D model of the universe, but it also includes time. It also indicates time as a four-dimensional continuum. The whole concept of spacetime was introduced by Einstein when he wrote his theory of general relativity in 1915. And using this theory, we can say that time flows at a slower rate the closer we are to Earth's surface. For example, if you were at the top of a tall skyscraper, time would flow at a faster rate compared to if you were just walking on a sidewalk. However, the time dilation in this case is barely noticeable because the distance between the top of a skyscraper and the Earth's surface isn't very large. Time dilation only becomes more noticeable when you go somewhere with a gravitational field that is significantly different than that of Earth. So a better example would be if you somehow manage to teleport near a black hole. You will obviously be crushed by its pressure, but for the sake of the explanation, let's say you don't. Since the black hole has such an enormous amount of gravitational energy, it bends space so much to the point where you start experiencing time much slower than an average person on Earth. 1 year near the black hole is said to be equivalent to around 80 years on Earth. But how significant would time dilation be if you were to go somewhere smaller than Earth? Fortunately, we may actually be able to find out pretty soon because NASA is planning on sending people to Mars within the next 20 years. So this got me thinking, how does time on Mars compare to time on Earth? And how would you celebrate your friend's birthday if they lived on Mars? A day on Mars is around 24 hours and 36 minutes, which is a little longer than a day on Earth. This makes things a little more complicated. But thankfully, we have this thing called a Martian Time Coordinated, also known as MTC. This is a special clock that coordinates time on Mars in relation to Earth. So if you want to celebrate your friend's birthday on Mars, all you have to do is look at this clock, and once the clock hits 12 or midnight, you can send your birthday message. Thank you.